project, right? You drop this infinitely strong cable from the moon all the way down to Earth. It sounds like an absolute engineering dream, doesn't it? Well, unfortunately, it rapidly turns into an apocalyptic physics nightmare. Let's dive right into exactly why celestial mechanics always have the final say. Seriously, just picture the sheer scale of this for a second. We've got this mega cable cutting straight through the vacuum of space, piercing right through our atmosphere, and aiming for this colossal anchoring point right here on the surface. I mean, it's the ultimate bridge, connecting humanity directly to the stars. But, before we go packing our bags for the Sea of Tranquility, we desperately need a pretty hard reality check. So think about it. The cable is extending down, right? The anchoring mechanism is totally ready to go. The tension is building up. But what actually happens the exact millisecond that cable clicks into place and the connection goes solid? Well, to figure that out, we kind of have to look past the fantasy engineering and look directly at the immense, mind-boggling physical forces that are about to clash.
Okay, let's dive into this down here on the ground. We have this absolutely incredible anchoring structure. We're talking superheated mechanical legs digging deep into the cracked earth, completely designed to withstand unthinkable stress. It is an absolute marvel of technology. But, and believe it or not, it's not the crane that's the failure point here. No way. The real problem, that actually comes from way up above.
And here's the crucial physics fact that totally ruins this entire plan. You see, the moon is not just sitting stationary up there in the sky waiting for us to toss it a rope. Actually, the moon is already whipping around Earth at over 2,000 miles per hour. I mean, just wrap your head around that. That is a completely unfathomable amount of kinetic energy just constantly circling our planet. Which naturally brings us to a really massive momentum problem. Think about taking the mass of the entire moon. We're talking roughly 73 quintillion kilograms. Now, combine that gigantic mass with that 2,000 mile per hour velocity we just talked about. You are basically taking the unstoppable forward motion of an entire celestial body and suddenly trying to tether it to a fixed point on Earth? Yeah, that's not going to end well.
And this leads us to a pretty terrifying reality. As the source material so perfectly puts it, all that speed creates an absolutely unstoppable amount of force. It really is that simple. Human engineering, literally no matter how advanced it gets, just cannot outsmart the raw, unbreakable math of planetary momentum. Now, what's really interesting about this chain reaction is the exact millisecond the connection happens. The second you attach that cable, the slack totally disappears. It pulls taut, and instantly the moon's momentum just takes over. That unstoppable force travels straight down our theoretically infinitely strong cable and just smashes into the anchor point. It's just too strong. Suddenly, the actual crust of the Earth itself becomes the weakest link in the chain. And this brilliantly illustrates the catastrophic climax, because that force would literally rip the crane right out of the Earth's crust. Since we're pretending the cable and the crane are hypothetically unbreakable, the immense momentum of the moon just simply tears away a massive chunk of our planet. It leaves behind this glowing, fiery crater. I mean, we're talking about a literal Earth-shattering transfer of energy in just a fraction of a second. So it's really the ultimate mismatch, isn't it? On one side, you have our most advanced theoretical engineering, right? An unbreakable tether and the absolute ultimate space crane. But on the other side, the raw, violent power of orbital mechanics. The universe just operates on a scale of energy that simply overpowers our wildest structural ambitions, pretty much every single time. So, I really want to leave you with this question to chew on. Can any human structure truly withstand the violent realities of space? Because when we dream up all these incredible sci-fi megastructures, are we actually remembering to factor in the terrifying, completely unstoppable forces of the cosmos? It really makes you wonder what other popular science fiction concepts completely fall apart the exact second you apply some basic physics.